Alright, we're going to get into some similar triangle proofs today. Really going to be kind of straightforward on these proofs, nothing too complex. Let's go ahead and get started with this first one where we have our given information already written down. To do this problem, I'm going to kind of refer really quick to the three ways I've got to show that triangles are similar. We've got side-side-side similarity, side-angle-side similarity, and angle-angle similarity. For this one, since I have no information about any of the angles, I know it's going to be side-side-side similarity. So now let's get to proving that the sides are in fact proportional. To do that, I'm going to go over here and I'm actually going to take this very first equation, AB equals 2, and say that AB does equal 2, but what I'm going to do is I'm going to divide on both sides of that very first equation and get that AB divided by FE. Why FE? Well, it's simple. AB was the shortest side, so FE is the shortest side. And now I'm going to put a 3 over here. I'm able to divide by the same thing on both sides on this equation because it already said that FE equaled 3, so I am dividing by the same thing. The property I'm using there is the division property of equality. Now, I'm going to kind of continue that process for some other sides. For instance, I can take the BC equals 3 and divide it by the same thing, which let's see what corresponds to BC. BC is the middle length side. The middle length side over here is ED. And I know that ED and 4.5 are the same thing, so I'm dividing yet again. This is actually part of statement 2 again. I'm going to do the same process for the equation AC equals 4. On both sides, I'm dividing by the same thing, which for AC, since it's the longest side is DF, which is 6. And I've done all that with division property. Now, one of these is actually simplified all the way down. I can see my ratio is going to be 2 to 3. That's great. These other ratios should also come out 2 to 3, and sure enough they do, if you just simplify them. So I'm going to say the BC over ED is equal to 2 to 3. You can do that by dividing by 1.5 on the numerator and denominator. Now, what I'm going to call this is I'm going to call this substitution. I'm replacing 3 over 4.5 with 2/3 in that equation. So substitution property. I can also do that for the other ratio that didn't come out to 2 to 3. So 4 over 6 is also 2/3. I can replace 4 over 6 with 2/3. So AC over DF is equal to 2/3 for the same reason. We'll make that part of the same step. Now for my statement number 4. And this is where it really comes in handy that I thought about side earlier. If I look at all the corresponding sides, they're all coming to the same ratio, which is 2/3. So AB over FE does equal BC over ED. That's using transitive property. They both equal 2/3, so they equal each other. And I can go ahead and tag in the AC over DF. So I'm going to write that in real quick. You can see I've already gotten that in with transitive property. They all equal 2/3, so they're all equal to each other. Technically, it's using transitive property a couple times there, but I'm just going to make it one step. To wrap up my proof, I'm jumping to the left here. That triangle ABC would in fact be similar to triangle FED. And the justification for that one would be side-side-side similarity. Here I did not make mention of what the similarity ratio is, but that wasn't part of the proof. It would have been 2 to 3. So we're done with this proof. Taking a look at example 2, where I'm going to get to is showing that the sides are proportional. What I'm going to have to do before I can do that is show that the triangles are in fact similar using the given information. There is a couple different ways to do this proof. But for me, what I'm going to do is I'm going to focus on the lines being parallel. I'm going to say that angle F is congruent to angle K. That's a conclusion I can make from that. That's because they are alternate interior angles. They were on different sides of the transversal between parallel lines. And that is a theorem. I could, while I'm at it, say the same thing for angle G and angle J. Now, some of you might be sitting there like, well, wait a minute. I could have said the vertical angles right here. Yes, you could have. That's a different way to go about the proof. But now that I've got two pairs of angles, I would know the triangles are similar. So I'm going to go ahead and make the statement that triangle FGH is similar to triangle KJH. And that's by angle-angle similarity. Again, if you had used the vertical angles, it would still be by angle-angle similarity after you used a pair of alternate interior angles. Moving right along, now that I know the triangles are similar, what that does tell me is that corresponding sides are proportional. Okay? So that's actually in the definition of similar polygons. That's one of the things that we wrote down day one of this unit. I would be able to make my conclusion that FH, which is first and third, does correspond to KH, first and third, which should equal the ratio GH, second and third, over JH, second and third. And that's coming from the statement right up here that I was trying to prove. Now, the reason why this is true is because the triangles were similar, and if they're similar, their corresponding segments have to be proportional. Now, you could say a few different things about why this is the case. I would accept something as simple as the definition of similar polygons, because that's what you're referring to. Some people want to make something like what CPCTC was for the last unit. Here, that phrase would not work, but what would work is writing out that corresponding segments of similar triangles are proportional. Writing a statement like that, you could actually write a sentence in there as a justification. And if that sentence is true, then I'm not going to argue with you. Really, though, you are just stating what the definition of similar polygons was. All right, that wraps up this proof. All right, that wraps up our day. Here's your two problems for homework. We'll check over these in tomorrow's class and see how you're doing with them.